Now it's time to meet the absolute value function and its family. What does it mean to be an absolute value function? A function is an absolute value function if its expression does two things. First, it contains an absolute value. And second, other than the absolute value, it's perfectly simple. It is otherwise linear. So what are some examples of absolute value functions? Well, the simplest one would be f of x is the absolute value of x. We could get more complicated, say g of x is negative 2 times the absolute value x minus 3. Or h of x is negative 2 times the absolute value 3x minus 4 minus 6. This is about as complicated as it's going to get. An example of something that is not an absolute value function, according to this definition, is something like this. Right? Notice that in addition to the absolute value, this expression has a power of a variable, which means that it breaks this otherwise linear rule. So what can we say about absolute value functions? The key thing about absolute value functions, and one of the major reasons we're studying them at this time, is absolute value functions are not one-to-one. What? Really? Yeah, let's consider this function g from up here. Let's see. G of 2 is negative 2 times the absolute value 2 minus 3. Arithmetic inside the absolute value first. Negative 2 times the absolute value of negative 1. The absolute value of negative 1 is just 1. And negative 2 times 1 is negative 2, of course. All right. But what about g of 4? That'll be negative 2 times the absolute value of 4 minus 3, which is negative 2 times the absolute value of positive 1. With these absolute value signs around, I feel like a little upsweep on my 1 so I can tell what I'm doing. The absolute value of 1 is still just 1, and negative 2 times 1 is negative 2. Right, so we see g of 2 is the same as g of 4. That means that two different values of x give us the same value of y. G is not a one-to-one function. And it's pretty easy just by trial and error to find these values that give us the same output. I'm going to have you do an example, again, just by trial and error. So let f of x be the absolute value of x plus 1. Complete this table, and then, based on what you see in the table, explain briefly how you know that f is not one-to-one. Pause the video and try this now. Okay, let's fill in the table first. Absolute value of negative 3 plus 1. That'll be the absolute value of negative 2, which is 2. Absolute value negative 2 plus 1. That'll be the absolute value of negative 1, which will be 1. The absolute value of negative 1 plus 1. That'll be the absolute value of 0, which is 0. The absolute value of 0 plus 1 is the absolute value of 1, which is 1. The absolute value of 1 plus 1 is the absolute value of 2, which is 2. Absolute value of 2 plus 1 That's the absolute value of 3, which is 3. Absolute value of 3 plus 1, that's the absolute value of 4, which is 4. Well, we can see that it's not one-to-one. For example, here we have cases where we get the same output, and here we have cases where we get the same output. How do we know it's not one-to-one? For example, -2 and 0 give the same output, namely +1.